Hello and welcome to another walkthrough of IAL Edexcel IAS level physics. And today I'm going to do a walkthrough of paper 2, unit 2, conducted in May 20 and 25. So you're going to have this exam next week. I wish you all the best for your exam. And I did this walkthrough in detailed way with all the techniques and tips and tricks that you need to remember for your exam for a good conduct of your exam. Okay. So before going into details, please like and subscribe my channel. I really need your support and your subscription. Okay, let's start. And also, if you need any private tutoring, you can also let me know in the WhatsApp or in the email. So question number 1, the refractive index of the vegetable oil is 1.47. Which of the following is the speed of light in meter per second in the vegetable oil? So when the light comes into the vegetable oil, of course, it bends towards the normal, right? Because the refractive index is more. So you just write N equals C over V and 1.47 into V equals C. So this was a straightforward question. And when you do it, your answer is 2.04 into 10 raised to the power 8 meter per second, which is this one. Okay, so array of light is incident on the boundary between the perspex and the air, as shown. The angle of incidence I is greater than the critical angle for the perspex air boundary. Okay, so you can see that this is the boundary of the perspex and air, and they are saying that here the critical angle is less while the incident angle is greater. So angle of incidence is greater than angle of criticality. This is what they have mentioned. And for such kind of scenario where angle of incidence is greater than critical angle, what do you have? You have three cases actually. Incident angle is less than critical angle. So when you have this, light bends away from the normal, okay? Number 2 is when angle of incidence is equal to critical angle, it means the light move along the boundary, And which boundary we are talking about? This boundary. Okay, and number 3 is when angle of incidence is greater than critical angle, we have total internal reflection. So this is what's happening here. So all the light has to be reflected. Reflected means you are not allowed to change the medium. Refraction and reflection. So in refraction, medium changes, angle changes, okay? This is the difference between reflection and refraction. In the refraction, your medium is also changed, and angle of incidence is not necessary to be the angle of refraction. And for the reflection, it is opposite to that, no change in medium. And angle of incidence is equal to angle of reflection. So this way your option is going to be C. Which of the following unit is equivalent to Coulomb? Coulomb is IT, so it's ampere and it's second, but not ampere per second, not an option. So also W over Q, from here Q is W over V, W is joule, where voltage is V. So that is the answer. B. Number 4. A student set up the apparatus as shown. When the string is plucked, it vibrates with frequency F. Which of the following single changes would increase F? Okay. So first of all, for this kind of setup, what do you need to remember? You have the speed to be equals to T over mu, right? And V is actually F lambda, T over mu, and for just one loop or first harmonic, if you say, or fundamental harmonic or first harmonic. Harmonic means loop, you can also say. So just the minimum loop you can have is just one. And for that, you have just half wave. This is not full wave. Full wave is this much, okay? So this is one half and this is one half. When you make these two halves added together, it makes a full circle. But this is only half of wave. So you say the length L is having just half of the wavelength. This one is not considered because it is the reflection. So we just consider the one which is on the top. Therefore, we just say length is actually equals to half of the wavelength because it's just half wave. So from here you get 2. All you need to do is just to put in here over mu. And from here, now I am going to have the frequency relation as T over mu. Now, we need to compare the frequency with length, tension, and mu, okay? So that is how you need to answer in the question when they ask for the dependence of one variable on the other. For example, here they are saying how the frequency will change. So it means they are now trying to compare the effect of frequency with length, tension, and mu, which is mass per unit length, okay? So you can easily see that frequency is inversely to length. So if you decrease it, your frequency is going to be increased. So right away, my option is going to be A, okay? And for B, C, and D, in the formula, we don't have mass, so no problem. We don't have area, and we have mass per unit length, but it is an inverse relation with the frequency is and it's written increasing. It's also not an option. So the only option is actually A. An energy level diagram for the hydrogen atom is shown. Arrows A, B, C, D show 4 possible electron transitions. Which transition would result in the emission of a photon with a shorter wavelength? Okay. So it is mentioned electron. Remember, it's not a photon. Okay. Oh yeah, sorry, it's photon. It's photon. Emission of photon with shortest wavelength. So energy of photon is E equals hf, but we know that photon travels at speed of light. So the energy the speed of photon is this C equals F lambda, and from here F equals C over lambda. So you just put E at C over lambda, and from here you are saying that the energy will be highest if the wavelength is shortest. So the energy is actually highest for this and this. If you see here, that is energy 0, and here's minus 13.6. So 0 minus 13.6. This is the highest energy that you can have for this kind of transition. So when you have the highest energy, you have the shortest wavelength. So you will say that it should be A. Okay. A negative temperature coefficient thermistor is connected in the circuit as shown. The temperature of the thermistor is increased. Which row of the table gives the changes of the reading on the ammeter and the voltmeter? This question always comes in exam, always come in exam, always come in exams. So you need to take the dummy numbers. First of all, just consider that this is a 10-volt battery, and according to KVL, whatever the supplied voltage is, it will be shared by the components of the circuit. So supplied voltage is equals to the consumed voltage, or you can say shared voltage, okay, because they are like going to share this voltage. So voltage is basically energy supply, and they are like eaters of energy, eaters, because they're resistors, so they are going to eaters, they will eat the energy. So 10 volt is coming, and just randomly divide the energy between them, so it's like 7 and it's 3, for example, okay, because KVL says whatever the supply you have, it will be equal to the distribution of the energy between the components. Well, ammeter and voltmeter is not the component of the resistor, they are just there to measure the current and um, uh, voltage, and once it is done, you can remove them from your circuit, no worries, okay. So now they have mentioned that the temperature of the thermistor has been increased, and we know that when temperature of the thermistor is increased, the resistance of thermistor is decreased. We know that there is an inverse relation between the resistance of thermistor and temperature. So when the resistance is going to be decreased, you have to take two dummy numbers, one for the voltage and one for the resistor, okay. So say that this is 10 ohms and this is 5 ohms, okay. So when the resistance decrease, you have to replace this 10 with, and the total resistance before drop in the temperature, it was 15, 10 plus 5, 15 ohms. It was previous resistance before T rise, okay, before temperature rise. Now when the temperature is rise, when T rises, you say RT is decreased, so you just take another number, say that it's now 6. So now total resistance is 6 plus 5 equals 11 ohms, okay. So when the resistance is down, what happens? I equals V over R, right? So from here we know that resistance and current are inversely proportional to each other, and from here we know that voltage and resistance are directly proportional to each other. So here, when the resistance is down, the total resistance of the circuit is also down. So when the total resistance of the circuit is down, it means the current is going to increase. So option for the ammeter is increase, okay. So the first two options are not true, because here they are saying ammeter is showing decreased decreased current. Now what about the voltmeter? So here you are saying the total voltage is the total resistance is decreasing. So when the total resistance is decreasing, the total reading also decreasing here. Therefore, the option here is D. Okay, so here we will down because R is down. The only option here is therefore D. Hope you understand that. So this is the question for the constructive and destructive interference. And you know that the two waves of wavelength 2 meter are produced by a source at point X as shown. This is a source X, which is creating um, which is producing two waves. One is traveling a path of, this is 1 and this is 2. Path 1 is about 4 plus 4, 8 meters, and path 2 is about 3 plus 6, 9 meters. Okay, so they are now having an interference here. Which of the following is the phase difference in wavelength? It means we are going to have destructive interference, and destructive interference means always 180. Okay, it always mean that you have a phase difference of 180. And for constructive interference, your phase difference is 0 degree or 360 degree. This is for constructive, and this is for destructive. So since here the path difference, which is 1, and wavelength is actually 2, and the path difference is actually 1, so we need to multiply wavelength 2 with half, which means that the path difference is actually first half multiple of wavelength. Therefore, it is going to have a destructive interference, and I'm going to write pi, which means 180. Okay, so option should be D. The cell in a solar powered lamp stores 6 kilojoules of energy. Okay, the lamp is switched on and cell discharged fully. The cell has a constant EMF of 1.4. Which of the following is the charge that passes through the lamp? Okay, so just do voltage equals work over charge. From here, work is VQ, and from here, Q is W over V. W is 6,000 divided by V, 1.5. So the answer is going to be C, 4,000. When monochromatic light is incident on the surface of a metal, photoelectrons are emitted. Which of the following statement is correct? The maximum kinetic energy of the photoelectrons depends on the intensity of the incident light. Okay. First of all, see that how do you make a photoelectric equation? For example, this is a sleeping electron, okay? In a metal piece. A photon is coming with energy 10 joule, okay? So the electron is actually bound inside a structure, so we have to break this bond. So when you are going to break the bond, of course you need some energy to break it, right? So say that you invested 6 joules in breaking it. Now electron is out and it's running. So when the electron is running, it is going to have kinetic energy. Now, do you think how much the kinetic energy it should have? It should have 4 joule, because 10 joule was the total initial supply. So 6 joule has been wasted or used in breaking the bond. So the only energy left for the electron to run is just 4 joules. So you will just write this equation: 10 joule equals 6 joule plus 4 joules. So 10 joule was the energy of photon, and the energy of photon is always HF. 6 joule is the work function. It means we need to do some work to break the bond. That is called work function phi. And 4 joule is the kinetic energy of the electron. So that is how you make the photoelectric equation, okay? So in this equation, you are saying that the frequency is depending on just the incident and photon energy. So if it is higher, everything will go higher. And if it is lower, everything will go lower, okay? Not this one, sorry. This is constant for material. It depends on the material. It's in fact not even constant, but it depends on material. Okay. So now the question is, the maximum kinetic energy of the photon depends on the intensity of the incident line. Intensity of the incident line means, for example, you are throwing two photons with energy HF, and now you are throwing four photons with HF. So you increase the intensity. It means the intensity increased, right? So if two photons are coming and hitting the electrons, of course, only two electrons will be out, right? But here, if four photons are coming, then it means four electrons are out. So it means that when you rise the intensity I, the number of emitted electrons also increase. But you notice that the incident photons number doesn't make sense. The real thing is the energy of the incoming photon. And if the energy, you don't change it, energy is just same. So HF equals 5 plus KE. And if you just keep the energy same and just increase the intensity, what happens? Won't provide additional energy to the electron. So what would it will increase, but just their number. Okay. So if you want to increase the kinetic energy of the electron, you have to increase the energy of the incoming photon. Okay. So the number of photoelectrons emitted per second depend on the frequency of the incident. No, it depends on the intensity. The maximum kinetic energy will depend on the intensity of the incident. And no, the maximum kinetic energy of the photon depend on the frequency of the incident light. Yeah, incident light means photon, right? So now that makes sense, because HF equals 5 plus KE. So if you're rising the frequency, it means you're rising the kinetic energy because they're directly to each other. Therefore, the only option is this. Two wires X and Y are made of the same material. The wires are connected in series. The current in the wire is I, as shown. Wire X has twice the diameter of wire Y. The mean drift velocity of the electron in the X is V. Okay. Which of the following is the mean drift velocity of the electrons in the wire Y? Okay. So I'm going to write the two equations for X and Y. The equation for the drift speed is this NQVA. And I need to find out the drift velocity. So first of all, I need to make velocity separate and shift all quantities on the other side. That is the answer. Okay. Now the material is same. So charge density is going to be same, and both are in series. This is also be same. And what else? Current is also be same because they're connected in series. So everything is constant. You're just left with A. So now here the drift velocity is inversely to A. So here you can see that the area is actually pi r square. So rather you need to write this, that the drift velocity is exactly um, uh, inverse of the square of the radius. So now it is the keyword that you need to look for. This has a diameter 2d and it has a diameter d, right? So for y, I'm just going to write y equals 1 over r squared, but for x, 1 over 2 r squared, because when you have double diameter, you also have uh, a double radius. So 4r squared. So 1 by 4 is actually is going to be 0.25, right? So it means my speed is going to have an impact of about 0.25. Therefore, the uh, option is going to be I think I did it for x, not for y. So for x, it's 0.25 V, but they are mentioning for y, okay. So for this, if this is the diameter d, then it is going to be half d, okay, diameter. So we need to write again 1 over a, and from here inversely to pi r square. Okay, so for y, they are asking to do the analysis, but first of all, x, for x, you just have this, and for y, you are going to write this 1 over radius half square, okay, because diameter means radius half as well. So from here, this 2 will go up to the numerator and it will become 4 over r squared. So from here, if I separate this and make this, so previously for x, it was 4 vx, and this is y. So the speed of electrons in y will be 4 times of the speed in x, okay? Therefore, the option is D.